Welcome everyone. My name is Matt Rose. I'm the field CISO at ReversingLabs, and this presentation is Beyond the SBOM because what you can't see can actually hurt you. Well, there's been a lot of discussion and executive orders and memorandums all around SBOMs and supply chain risk. But I really want to demystify a few things and talk about what an SBOM brings to the table and what kind of things it lacks, what it's not really doing, and why just having an SBOM is not the end-all be-all for the security and the attestation of your applications. So let's start out with, kind of the first step of this equation, where there was an executive order issued by the White House. It was in May of 2021. And it basically started the conversation around really hardening the cybersecurity resilience of the federal government. That could be civilian agencies, DoD, so on and so forth. But then this year, and there was a memo issued, and that memo basically really talked about self-attestation for organizations that wanted to work with the federal government and, providing an SBOM or explaining what was in the applications they were doing it. This came out just a couple months ago. It was, September of this year. So these things are kind of building on each other. And really the interesting thing about the memo is saying they're not going to mandate a SBOM for organizations, but they highly suggest it. So stay tuned. There's been some more information that's going to come out. But really thinking about the combination of the executive order and the memo combine into these things in terms of SBOMs are going to be really important in the not too distant future. So let me just erase this. So really when we're talking about SBOMs, a lot of times organizations say they have an SBOM or they provide an SBOM, and there's different technologies that did. We have different formats. SPDX is one format of an SBOM. We also have SWID, and then the last one is Cyclone DX. I actually recently ran a poll on LinkedIn saying, which format do you use for your SBOM, so on and so forth, and the resounding winner was Cyclone DX. So when you're thinking about SBOMs, there is a format, there is a proper kind of structure to a SBOM, but what we're going to talk about is going beyond the SBOM. Once you have this SBOM, is that enough? What should I do next? So let me just, we'll move in and we'll turn off the lights and we'll focus on the presentation itself. So really when you're thinking about software, thousands of files make up a complex supply chain of open source and commercial third-party packages that basically allow you to build software. How can you trust that they don't contain vulnerabilities, malware, ineffective mitigations, or indicators of supply chain compromise that put your applications at risk? So really just the SBOM, does that really solve all of those specific problems? So when we're thinking about an SBOM, the product name, the version name, the publisher, the licensing, is it allowed to be used in a commercial software? That's all really important, and they're all elements of a SBOM or software bill of materials. But you need to be able to go deeper at the file level. There you can gain really actionable information into all of your software files and protect your applications from cyber threats. So really thinking about it is not just the details of an SBOM, which we'll go into in a second, but going a step further into the file details themselves. So a list is just a list. So when we're thinking about a list, an SBOM created from software composition analysis tools really just give you that high-level snapshot of the components embedded in your application. Each of these components is made up of hundreds and sometimes thousands of files. So just thinking about the information here, and we see this on the screen, things like the product name, the product version, the publisher, and the licensing, and we'll kind of go through these in a second. The challenge for the software developer is that threats and software issues exhibit themselves on a file level, not a product or publisher level. So we'll just give some examples from some of the things that a software composition and SBOM would basically provide you is really, a file, the product name of the file, TK8 or PIP, so on and so forth. The product version, 15.14, 9.01, what is the version? Who actually published the software? Whether it's an individual, whether it's a corporation like Microsoft or Google, or an individual itself. And then licensing concerns. These are all very kind of problematic issues where you use an open source package and then you insert it into a a commercially available or a commercial piece of software for sale, you're breaking that licensing agreement. So examples of that is LGPL, MIT, BASD, Apache, so on and so forth. So thinking about all these things, this is just a list. But as we move in, we can see that, what if you could get insights into every component? A complete report gives you all of the information of an SBOM plus individual file insights. You get an actionable information you need to remediate problems and build secure software. So there's a bunch of different things here. I'm not going to basically highlight them here because we're going to get much deeper in that. So really thinking about my package itself and the SBOM, one of the first things is getting a quality grade. Start with the big picture. A lot of what's in your package is nice, but wouldn't it be better to have a full kind of list of information and what you can do with it? With the ReversingLabs report, this is our example of an SBOM in a full report. Your starting point of the software quality guide, which allows you an overall grade of the application itself, based on not only the things that software composition analysis, but also file and reputational information. Once you have an idea of the overall quality, you can start digging into and doing more research at a much more granular level within the application itself. The second piece of this equation is verified component. Is it what it claims to be? So is this, software package, valid? Is there malware in it? The report will identify which components have been verified, which ones are, they are what they are, and against the reputational kind of database and list to really understand where there's potentially things that are not, copacetic, if you will. Is the identity exactly what you see in the report? The package, was there package tampering found? Contains no malware. Okay, was there malware, but is there malware that's been covered up? Are there signatures or characteristics that say, hey, there might have been malware here at one point, and it looks like it's been somebody's kind of covered their tracks. Risks and issues tracking. So really kind of like an ingredients list that you see on everything in the grocery store. Easy remediation and prioritization is if you can see what type of things are in there. This, ingredients list or kind of SBOM facts graphic really says, here are the things you need to look at and give you a path to investigation and understanding of the risk within the application itself. Some really, I found something, I need to fix it. How do I prioritize? This really helps you down that path and gives you that breadcrumb trail to find out what the risk is and how to actually fix it. So as we move through, the last issue here that we're really going to talk about is unexpected behaviors. And this is, again, I kind of mentioned this previously. I gave a little foreshadowing in that there are some times that malware is hidden. So it's basically novel, as some people like to say, where it's never been seen before, but you see certain things that are basically done in the application. It creates a secure connection, it uploads a file to a secure connection, uploads a huge file to an unknown URL. That's not something typical the application does or is intended to do based on your knowledge of the architecture of the application or reverse engineering of a threat model, for example. And basically this path and this kind of sniff test that you give an application is not something that is typically done by just a rudimentary SBOM in the SPDX or SWID or Cyclone DX type of example. So again, it's not just the who, what, when, where, why. It's about that investigation at the file level, not just at the application level. So as we move forward in the presentation, start releasing securely. SBOMs are a great thing. Executive order, it basically mandates, so it's not mandates yet, but with the memorandum really talks about SBOMs being the best way to self-attest to basically say your software is secure. But there's a lot more than just the SBOM. Understanding all the basically intricacies of the files themselves and not just a list really helps you identify risk in an application from a supply chain risk and really let your customers and your internal stakeholders know what is happening with an application, what you need to do, and how you need to investigate based on the things that you're seeing as part of that reverse engineering of an application. So this presentation, as you saw, and I'll turn up my lights here, was really, I'll put my glasses back on too, about the SBOM is a great thing. Really think that the value of an SBOM helps organizations basically communicate risk, communicate potential unknown. But actually, just an SBOM in a just a narrow vision, tunnel vision type of thing is not the end all be all. You really need to actually tear apart the application and find out not only the intricacies that SCA finds in terms of an SBOM, but all the file and reputational database information you can provide. I'm Matt Rose, Field CISO at ReversingLabs. Thank you for watching. Hope you enjoyed the presentation.